Hello, everybody. Welcome to today's episode of BMSC Live, which is all about oceanography. We're here in Bamfield, British Columbia, on the west coast of Vancouver Island, in the heart of the territory of the Huu-ay-aht First Nation. My name is Kelly. I'm an educator at the Bamfield Marine Sciences Center, which is actually just here beside me. And we are a not-for-profit registered Canadian charity. We're also owned and operated by 5 different universities, which are the University of Alberta, University of Calgary, Simon Fraser University, the University of British Columbia, and the University of Victoria. So all 5 of those universities have a hand in our operation. What we do is host researchers who come from all over the world to do their experiments here at Bamfield. We also run 4-credit university courses as well as field trips for school groups. So if you like what we're doing and you want to see more, please consider making a donation to BMSC. There's a link to our website in the video notes, and you can follow the instructions there for how to make a donation. I'd like to give a shout out to Joanne, who recently made a donation to BMSC. Thank you so much, Joanne, who is an alumna of BMSC. I'd also like to acknowledge funding that comes from NSERC Promo Science in making this show possible. NSERC has been supporting our educational programs for many years, and without their support, we wouldn't be able to do shows like this. So thank you to NSERC Promo Science. Now, in case you're wondering, you've obviously noticed by now, if you're a longtime fan of our shows, I'm not your usual presenter. Don't worry, fans of M is still very much a part of BMSC, but has now started a master's project. So I'm your new presenter. My name is Kelly, in case you missed that part at the beginning, and we're here to talk about oceanography today. I'm going to introduce you to the rest of my team. However, before I do that, I'm going to ask you a question, and hopefully you guys can chime in with some answers. You can use the comments or the chat function to ask or answer questions, and then we'll get back to those as the show goes on. So my question for you to start out is, what is oceanography? What are we even doing here today? Let me know in the comments, and I'll get back to that in just a second. So while you're typing, I'm going to introduce you to my teammates. There's 2 people helping me out today. The first one is on the boat with me right here. She's going to flip the camera around and say hi to you. This is Stacy, everyone. You may have met Stacy if you watched our Alta adventure show. She was the skipper of the boat on the Alta show. But today she's our videographer, so thank you, Stacy, for filling that role for us. The other member of our team, he's also watching through a screen just like you are. He's back on campus behind me, and it's Phil up in the whale lab there. So we'll turn things over to Phil for a moment, and he's going to show you a map of where we are.
Thanks, Kelly. Hi, everyone. Phil here. So for those of you who haven't seen our show yet or have been to Bamfield, just share with you a little bit of a site as to where we are. So here we have on Google Earth, North America. Vancouver Island is on the very west coast of here. And as we scroll in, you'll see that we are on the west side of Vancouver Island. Here we have Barkley Sound, just a long bay filled with islands and channels, and Bamfield is down here at the south end of Barkley Sound. And the science center is right here on this point. So we have our main building. I'm in the whale lab right here. And Kelly is just at the mouth of the harbor, right around here. If I just flip over to a webcam, you'll actually see Kelly out in the skiff. So there's Kelly right there, cruising around, ready for the show. All right, Kelly, back to you.
Thanks, Phil. All right, so let's get started. We'll take a look at some of your answers to my question, what is oceanography? Did anybody come up with the correct answers? Oh, okay, Stacy passed this along to me. Chaz, hello out there. You answered that it's the study of the properties of the ocean, and that is correct. So we're studying the ocean, but the ocean is a big place. There's a lot going on out here. We're right here in Bamfield Inlet, But this is only a small corner of the Pacific Ocean. There's a whole lot of other ocean out there around us. We're looking out into Trevor Channel, and beyond that, the Deer Group Islands. The whole area out there is Barkley Sound, but that's actually just a very small section of the Pacific Ocean. So if you are doing oceanography and studying the ocean, there's a lot of different ways that it can be studied. And oceanographers are the scientists who make that their profession. They do that for a living. So oceanography, the study of the ocean, and the oceanographers are the people that do that. Today, you are about to become an oceanographer here with me. That's the fun part. And I'm going to introduce you to a number of tools that oceanographers use. We're going to start with this one right here. So this one is called a TS meter. And I want you guys to let me know in the comments what you think the T and the S might stand for. It measures these properties that start with T and S. And let me know what you think. I'll explain how it works while you're typing. So it has a nice long cord on it, and it can measure the water at different depths. The cord is about 10 meters long. This part here on the end is the part that does the measuring. And then it gives me the numbers right here on the screen. So it's pretty easy to use. I just turn it on and it starts working right away. And it measures something that starts with T and something that starts with S. So did anybody answer those questions? A plus goes to Chaz Francis once again. Temperature and salinity. Oh, also, Karen, welcome to the show. Temperature and salinity is the correct answer, and that this instrument measures both of those things at the same time. So I've turned it on now, and maybe you can see this. I don't know how the sunlight is on our screen. Maybe if we go from this angle. Can you read that? Might be a little bit tricky. All right, you can't see that, but I'll read the numbers off to you. And actually, Phil back in the lab is going to be recording this information for us here. So the salinity of the ocean is 22.4 parts per thousand. This is right at the surface. And the temperature today is 17.5 degrees, a balmy 17.5. This doesn't happen in Bamfield very often. So Phil's going to record that information for us. So the way that this probe is working, it has a thermometer down on the water right now, so it's able to just record the temperature digitally and put it on the screen for me. It also measures salinity by actually measuring the rate at which an electric current passes between two electrodes. So the faster that happens, the saltier the water, but it just tells me the number right here on the screen. And I'll explain the salinity for you at a little bit more detail here in just a second. But first, I want to keep on taking these measurements. Maybe you guys can help by making a prediction as we take these measurements. So the temperature and the salinity are probably going to change as we go deeper. What do you think will happen? Let me know in the comments if you're confident about this. Is it going to get colder as we go deeper or warmer as we go deeper? And also with the salinity, will it get saltier as we go deeper or will it get less salty? Let me know what you think, and we're about to find out for real. So now we're at half a meter. Our temperature is 16.7 degrees and our salinity is 24.4 parts per thousand. Okay, moving on. We are now at 1 meter. Salinity is 24.8. The temperature is 16.6. And from here, we're going to go down in 1 meter intervals. So the next one is 26.7 parts per thousand salt and 15.2 degrees Celsius. Is there a question coming through? Okay, some people have made predictions of whether it's going to get saltier and colder. So let's hear them. Awesome. Raphael and Dylan say they think it's going to get saltier and colder. And hello, Dylan. We know your dad. Ah, okay, but there's also a prediction that it might get less salty and colder as we go deeper. So now our next data point, we're at 29.9 parts per thousand salt, and our temperature is at 12 degrees Celsius. I'm not at the end of the cord yet, so let's keep going. Down to the next one. Oh, we are at 30.3 parts per thousand salt and 11.3 for the temperature. Do you remember what the temperature was at the beginning? It's okay. It's okay if you don't, because Phil's going to graph this for us later on. We're going to look at it. But it was a nice warm 17 something degrees at the surface.
That's right.
Now we are
17 and a
down.
half.
Now we are down at 10.9 degrees. So I think we're answering our first prediction. Those of you who guessed that it was going to get colder as we go deeper, you're absolutely correct. It is getting colder as we go deeper. The salinity, on the other hand, seems to be increasing. I forget if I told Phil this data point. 30.6 and 10.8 degrees Celsius. Normally I have a boatload of students who can be recording this information for me, but today it's just me and Stacy out here. So Phil's got to do the hard work for us back in the lab.
On Kelly?
All right. Yes, Phil has a question.
So yeah, prediction from Claire on YouTube says she thinks it'll be less salty.
Claire thinks it'll be less salty. Thanks, Claire. I think we're actually finding the opposite, though. I think it's getting saltier as we go deeper. Our salinity is now at 30.7, and our temperature here is 10.4. We're going to go all the way down. Actually, let's go right to the end of our TS meter now. We're going to go all the way to the bottom of our cord as far as we can go. Take one last reading. Okay, the final salinity. It's not quite 10 meters deep, but almost. 30.9 parts per thousand and 10.1 degrees is the temperature. Did you get all that, Phil?
Yes.
Great. So in case you were confused about what I'm actually measuring in terms of salinity, when I say that the salinity is 30 parts per thousand, I've got a little visual here to help you visualize that. Let me just get my instrument back up out of the water here. So the salinity did increase as we went deeper. It got saltier as we got deeper. And maybe some of you guys at home will be able to tell me why that was. Why does it get saltier as we go deeper? You can answer that in the comments. And this will help you to understand a little bit about the salinity. So I measured this out. This is a little jar that contains 30 grams of salt. And in a normal seawater sample, any ocean water sample, normally around Bamfield at least, if you take 1 liter of seawater, this is a 1 liter jar, it will have about 30 grams of salt, which is just about 2 tablespoons of salt, kind of about that much. So just to kind of put that in perspective for you, what it is that we're actually measuring with this salty ocean water here today. Great. Did anybody predict why it gets saltier as we get deeper? Somebody made a prediction. Stacy's telling me the answer. Yeah, a couple of people, Chaz and Raphael, said that salt is heavy. And that's kind of the case. So salt water is actually more dense. The molecules pack together a little more tightly, and so they sink down deeper underwater. The surface water is a little bit less salty, the molecules are less dense, and all the salt water sinks down to the bottom. The same is actually true for temperature. So we noticed that it got colder as we went deeper. A lot of you predicted that that's what would happen. And that's because of density. Cold water is actually more dense than the warmer water at the surface. So that's why we get that layer of colder water down below. In a little while, Phil will be able to show us a graph of our data that we just collected. But while he's doing that, I want to move on to the next tool and show you how it works. This it's kind of a simple one, but it's a great tool to add to our oceanography arsenal of measuring devices. This one is called a Secchi disc. And you at home can use one of these too if you're located near a freshwater body of water. Doesn't have to be the ocean, but today we're going to try it out in the ocean. Maybe some of you have used one of these before. If you have, let me know or maybe you just know what it does. Let me know what it's actually measuring here. I'm going to put it over the side of the boat, just like we did with our TS meter. And this time I'm going to be watching to see how far down the disc can go before it disappears from view. So I may be able to see this longer than you guys can on the screen, I'm not sure. But I can still see it. It's going down over the side of the boat. Down. I can still see the white bits on the disc a little bit longer. Oh, it's getting hard to see. It's down pretty deep now. I think I lost it. I can't see it anymore. All right, so now what we're going to do, what we're measuring here has to do with the optics and the visibility underwater. Great word. So turbidity is the answer. If you've never heard of turbidity before, don't worry. Basically, it's a measure of how murky or clear the water is. And so this is important to measure for a couple of reasons. But let's get this out of the water and I'll actually measure what our depth was today. And then I'll explain what's happening. So I don't know if you noticed as I pulled this up out of the water, I kept my finger on the string in that exact spot from the surface of the water. And now I need to figure out the depth at which our Secchi disc was lost from view from me looking over the side of the boat. And this will be a good indicator of the turbidity or the visibility underwater. Here we go. So I'm just gonna run my measuring tape along the string. Oh, a little bit stuck here. Here we go. All right, measuring the string. Again, I usually have a boatload of students to help me with this part, so it's a little trickier on my own. All right, here we go. Here's our measuring spot. Not sure how well you can read this, but we're at 4.5 meters, 4 meters and 50 centimeters is our data today. And so what does that mean? Well, basically, we put the Secchi disc over the side of the boat and we were able to see it for 4.5 meters underwater. I think there's a question from somebody. Chaz wants to know if that's pretty clear compared to other measurements, and that's actually about average. So what's happening here is the turbidity changes pretty much on a daily basis. It depends on a number of different factors, such as if there's been a big storm, maybe that stirs up sediments in the water, or if there's a plankton bloom, that creates a lot of extra organisms and life in the ocean, and that affects the visibility underwater as well. So 4.5 is about average for this time of year, but again, it's really important to keep taking Secchi disc readings for over a long period of time and monitoring how the changes happen. I just found out that BMSC has been recording both the TS meter data and the Secchi disc data for over 20 years now. So you guys here today, by taking these measurements with me, are actually helping to contribute to this long-term data set that that BMSC has been building for many, many years. So thank you for your assistance in this really important project. Okay, the other thing that is useful with the Secchi disc is it can actually tell us where it measures a thing called the euphotic zone. So what that is there's the sunlight is hitting the surface of the water, and there are a certain type of organisms, living things, that require sunlight in order to do photosynthesis. And maybe if you watched our plankton show, you might know what these organisms are called. So let me know if you think you have the answer, type it in the comments. What type of organisms are found living near the surface of the water and they need sunlight to survive? Ah, Linda, you have the answer. It's phytoplankton. You're correct. So the phytoplankton requires sunlight in order to photosynthesize, and they can only live in the photic zone that we just measured with this Secchi disc. So that 5.4 meters, if they get bumped deeper than that underwater, they don't have enough sunlight to survive. And of course, there's still a little bit of light deeper than 5.4 meters, but it's not the full spectrum of sunlight that we're getting up here top side. So that's another reason why it's important to actually be measuring with the Secchi disc. Phil has let me know that he actually has that graph ready with our data from the TS meter. So let's take it back to Phil's screen and you guys can see the results in a visual form.
Thanks, Kelly. Yeah, so I put the data together for everyone. Here's what we get. So we notice a trend. So the salt line here is in blue. Here we have our depth in meters down on the bottom there. So 0 is where we started. 10 meters was at the end. And our temperature and salt, they range from 0 all the way to just over 30 parts per thousand for the salt. So the temperature and salinity are actually sharing the values there. The blue line is our salt. So we started right around 22. As we went deeper, increased all the way to 30.9. So you notice how this flat right here, it's more of a plateau, I guess, where there wasn't very much change. So the changing portion is right around here between 2 and 3 meters, the biggest change. Temperature, we went from 17.5, so very high, swimmable, quite warm right now, all the way to 10.1. So chilly once you get down to 10 meters. You definitely don't want to be down there. Again, our density change was right between 2 and 3 meters. So for the salt and the temperature, they changed their density right around 2 to 3 meters. For the salt, the change in density area is known as a halocline. And for the temperature, the change in density zone is known as the thermocline. So there you have it. Just this beautiful graph showing the trends that we normally get this time of year. Back to you, Kelly.
Great. Thanks, Phil. I can't see the graph from where I am on the boat, but that was an awesome description. Thanks, Phil. I have another set of measurements that we're going to take here on the boat today. While Phil was talking, I collected a water sample. I just fished a bucket over the side of the boat and I just pulled up some water from the surface here. And now we're going to use that water sample to measure the pH of the ocean. So the pH, if you're not familiar with that term, it's kind of a measure of how acidic the ocean is. And what I'm doing is just collecting 5 milliliters of water into a test tube here. And I'm going to add a solution that will change color depending on what the pH is. So this works specifically with salt water here. And all I have to do is add 5 drops into my container, my little test tube. There's 5 drops. Put the cap back on. I need a cap for this thing, which I put in my pocket just a second ago. And then we mix it up. Nice. It's a pretty color. And the way that this works, I have to match the color of my test tube. I don't know how well you guys can see this. Yeah, to the color of the chart that is provided here. And so the pH of our sample today, what do you think it is? Looks like it's around, it works better for me if it's in the sunlight for sure. I think it's around 8, 8.1 maybe.
Emily or Em says 8.2, Raphael 8.2.
Yeah, you guys think 8.2. All right, I'm going with what you guys are saying. So our ocean pH here today is 8.2. And what that means, the pH scale is a scale that goes from 0 all the way up to 14. And numbers that are closer to 0 are a little more acidic, and numbers that are closer to 14 are the opposite, which is called basic or alkaline. So pH of ocean water, our ocean water here today is about 8.2. Normally anywhere above 8 is pretty normal for the ocean. Phil actually, I think, has a chart of the whole pH scale that you guys can see. So let's put that up on the screen for a second.
Yeah, Kelly. So looking at this photo here, this image, it's not the same color scale that you were using. Neutral. And neutral is things like water, pure fresh water. Also blood is a pH around 7. And then all the way down to the acidic part, so acid, gastric, so your stomach acids right there. Soda pop is in there. Vinegars would be in there too, between 2 and 4. And then all the way to the other end where you have ammonia, baking soda is there, bleach and drain cleaner. So very alkali, which can burn you. Alkaline things will burn you, similar to how acids burn you. So here we have seawater right over 8, right there, as it should be.
Great. Thanks for that, Phil. So it's really handy to be measuring the pH of our ocean water. It looks like ours is pretty healthy here today, but this is something that scientists are studying a lot in the news right now, or in it's a big topic in the scientific community, ocean acidification, because sometimes what happens is with an excess of other chemicals in the water, such as carbon dioxide, it can actually change the pH of the ocean. It can go from this healthy 8.2 on the pH scale down into the more acidic ranges. And of course, there would be a whole bunch of impacts for the animals and the plankton that are living in the ocean if such a thing were to continue. So scientists are keeping an eye on that kind of thing. Unfortunately, I was only able to measure the pH of the surface water. There would be more sophisticated tools out there that scientists could use to measure the pH of other depths of water. The tools that I've shown you here today are pretty basic oceanography tools compared to the grand scheme of oceanography. But this is just a little teaser introduction to get you guys thinking about it. And then you can always learn more about oceanography later on. I'm curious to know if there are any questions coming through on either YouTube or Zoom. Anything on YouTube, Phil, that I might have missed?
No, it's pretty quiet over on YouTube. Remember, everyone, this is an opportunity for you to ask questions. Just way back, I forgot to mention how Claire's guess was that the water is probably heavier as you go.
Yeah, Claire, you were right when you said the water was heavier. And so that was that density thing that we talked about with the TS meter, measuring temperature and salinity. The colder water is more dense and the salty water is more dense. So that's why you see more of those waters layering down in the bottom. Luckily for us, it's not raining today, but if it was raining, sometimes the salinity of the surface is 0. It's fresh water on the surface. There's another question. Oh, great question. Dylan Porter is asking, how deep is the water underneath us right now? And to answer that correctly, I have to turn on our depth sounder here. So give it a second to start up. What this is an instrument that's attached to the bottom of our boat, and it sends a little signal down and it bounces off of the bottom and tells us the depth. It's kind of like how bats echolocate. So our depth today, I don't think this is working properly. It says 2 meters. I don't think that's correct. I think we are deeper than that. We are probably in, I would say, probably about 20 meters of water, probably right here. Yeah. Oh, looks like we're gonna have to get Dave Porter to have a look at our depth sounder and get it working properly again. Great question, though. All right. Any other questions coming through? Thanks, Dylan. Dylan's gonna tell his dad. Awesome. All right. Well, if there are no other questions coming through, then I'd like to take one last opportunity to thank my teammates here today for helping me out. So big thank you to Stacy behind the camera there for doing all this awesome filming and helping me to keep an eye and make sure I'm not getting too close to the rocks at shore here. And also a big thank you to Phil up in the lab for his contributions with making the graph and helping to make sure all the technology goes smoothly with this show as well. And of course, I couldn't do this today without you guys at home. Thank you so much for tuning in and asking all those questions and answering all my questions. That's really awesome. Once again, a reminder, if you like what you see here, you can always make a donation to BMSC, and the link to do so is on our website. Or you can just find out more about what BMSC does by visiting our website as well. Thank you so much for tuning in, and we'll say goodbye.